All right, guys. So, good morning, good afternoon. It's good afternoon, right? Yeah. Anyway, this is Mr. Campbell here. I will not be in today. Clearly, I will not be in Monday, November 29th. I forgot I had a doctor's appointment, and this guy only comes into work once in a while. So, well, I have to make do when I can. What we're going to do today, just because we really can't stop moving forward, we are going to be going over 2.4, which is 2.7 inside the textbook. Okay, proving angle pair relationships. Now, some of these are going to seem, well, duh, especially from the outset, especially with the first one we're going to be doing. But remember, to prove something in math is to really show beyond any doubt, any argumentation, usually, against it. So we really have to show everything. Pretend like you're doing this for someone who doesn't know anything's sake, like a baby with higher language skills or something, okay? All right, so the first thing we're going to prove is the right angles congruence theorem. All right, let's just go ahead and start with what's given. What was given here is that angle A and angle B are right angles. Okay? How did I know that? I was given that information. Okay, step 2. What does it mean to be right? Well, it means to measure 90 degrees, right? So, all right, forgive my family in the background. We're just hanging out on Sunday. All right, well, how do I know that it's equal to right angles? How do I know, rather, a right angle is equal to 90 degrees? Well, I know what a right angle is, right? I'm using my previous knowledge. Whenever you're doing that previous knowledge is because you know the definition. So this is definition of right angles. Okay, let's keep going. If they're both equal to 90, what do you think that means about A and B?
Computer, stop.
There's an alarm there. Okay. What do you think that means about A and B? Well, it means that they're equal, right? And you could reason this two different ways. You could think of it as transitive property, right? And ignore left and right distinctions. Or we can just do substitution property, which is probably what I'm going to do here. Okay, so if two things are equal, we know that also means that those things are congruent. That's the definition of congruence. So what do we know now? We know that if I start out with right angles, I can skip all this stuff and go right to A being congruent to B, angle A being congruent to B. So I don't have to do any of this 1, 2, 3, 4 anymore. I know that essentially I don't know why I did that in caps. All right angles are congruent. That's a very watered down version of what the right angle congruence theorem is. I guess we really should put it in an if-then statement. So if two angles are right, then they are congruent. Okay, congruent supplements theorem. Sounds really tough because this is congruent supplement. I'm not an English teacher, but that's a lot of syllables, right? Relax. It's really easy. So we're going to go ahead and say, since angle 1 supplements angle 2 and angle 2 supplements angle 3, what does that then lead to? Okay? So we are told, in a sense, we are given that angle 1 and angle 2 are supplementary. Okay, we are also given that angle 2 and angle 3 are supplementary. That was kind of given to me here. Okay, so given. We also know this definition of supplementary, and it's kind of just there to remind you. Okay, but you should already know that. Okay, but anyway, there's a reason they told us that. If angle 1 and angle 2 are supplementary, what's that make them add up to? Well, 180 degrees. Now that might not seem super obvious to you, or maybe it does, okay? So if you're told something like this, you can always think about ways of rewording it, or maybe getting into equality land, right? Like we have here. Similarly, if 2 and 3 are supplementary, this means the same thing about angle 2 and angle 3. How did I know this to be the case? That's the definition of supplementary. Well, we have a similar situation as we did before, up here, right? Oops, not what I wanted to do. Right, 2 things here equal 90. And here, while you might not think of it, oops, this is still a thing, right? M1 and M2 is still a thing. So I have 2 things which equal 180. What do you think that means about these 2 things? Same thing that I meant last time, that they are equal to each other. All right, and you can get there same as before, either through transitive property, ignoring left and right distinctions, or you can just use substitution property. Now notice, what's on both sides of this equation? What can I then thus get rid of? 2, right? So I know that angle 1 must be equal to angle 3. And maybe this one wasn't so obvious to you from the get-go, right? We, of course, get there through the subtraction property of equality. Okay, so maybe this wasn't so obvious to you that if 1 and 2 are supplements and 2 and 3 are supplements, what does that mean? That means that not only are angle 1 and angle 2 equal, they are then, of course, congruent. And, of course, this is by definition of congruence again. All right.
Go get your caterpillar.
And that's the case every single time. So in words, if 2 angles are supplementary to the same angle, then those 2 angles are, of course, congruent. This is the exact same proof. And to save time, which I know is super valuable, I know you guys are super, super busy, lots of important things to do, I'm going to skip over this one because it's essentially the same thing. You know what? Let's do one better. Instead of me doing this for you, why don't you do this one on your own? And we'll go over it on Tuesday, okay? So follow the exact same format as the previous one, but instead of supplementary, we're talking about complements, okay? All right, the linear pair postulate. This is always kind of like an argument sometimes with students, because they say to me, like, duh. It's one of those situations where you're like, well, of course it is. But technically the definition of a linear pair, if you recall, are 2 angles both, well, actually no, I'm saying the wrong one again. There are 2 angles which are adjacent. They share a vertex, and their non-adjacent sides form opposite rays. And if you don't know what an opposite ray is, I recommend you go ahead and look that up. Okay, so linear pair is technically 2 angles adjacent to each other, sharing a vertex, and Their non-adjacent sides form opposite rays. And if you don't know what an adjacent angle is, you have to look that up too, because at this point it's review. All right, so given this definition, this is the visual situation that we have set up here. Some of you might say to yourself, well, something else is clearly obvious here, right? Particularly when I pay attention to this line. All right, that's why I'm not really going to prove this. You also can't prove it because it's a postulate, so it's so obvious to everybody here. That's why it's called a postulate. If two angles are a linear pair, then what else are they? Well, they form a line. So what do you think these two angles would add up to? If you said 180, you're right. But we know that the term for two angles which sum 180 is supplementary. Okay? So that's the linear pair postulate, sometimes referred to as simply LPP. So when you go from a linear pair being stated to they equal 180, and you cite definition of linear pair, you're incorrect. You should state linear pair postulate. Okay, you know what? Let's do some examples here. Okay. Because we've just been doing nothing but these proofs here, and might be getting burned out. Hold on a second. Huh. All right. Well, I have the wrong examples on my notes. Let's just roll with it. Let's just finish up this last one here, and then I'll make a separate video for some of the examples down there. Okay? Okay, so vertical angle congruence theorem. Some of you guys might have already heard about this. Some of you might have an idea about what the definition of vertical angles are. Vertical angles, if you remember, are angles which share a vertex and whose sides form opposing rays. So just to visualize this for everybody here, let's take 1 and 3, right? These are vertical angles as stated. So this side is an opposing ray with this side, right? And this side is an opposing ray with this side. That's how that works. All right, anyway, let's get to it. I'm told the angle 1 and angle 3 are vertical. Although I don't think we need to state that so much. Let's state it anyway. Angle 1 and angle 3 are vertical, and I can state the same thing about angle 2 and angle 4 are vertical. Now, we don't know much about vertical angles other than the definition I just recently cited, so we're probably just going to leave it there for now. Looking at this diagram, anything else I see? I see some linear pairs. So let's go ahead and state those. What are my linear pairs? Let's just say angle 1 and angle 2 are linear pairs. And let's go ahead and say that angle 2 and angle 3 are linear pairs. All right, and you can, of course, observe those by definition of what a linear pair is. That's how I'm able to observe them. If they're a linear pair, then what are they? Well, they are supplementary, right? Okay, what was that again? Linear pair postulate. We just went over it. All right, if two things are supplementary, then of course they have to add up to 180 degrees. I'm realizing I'm going to run out of room. Oh, wait. I can go ahead and skip that part. I was just going to add them up and set them equal to an 80 and then set them equal to each other, but I already know something. Aren't angle 1, oops, isn't angle 1 and 3 supplementary to the same angle? What's that make angle 1 and angle 3? Makes them congruent. And that was by congruent supplements theorem, right? So I can skip all that business. Actually, I can probably take this and move it over. Okay, so that was by the congruent supplements theorem. All right. Now, we just showed that angle 1 is congruent to angle 3, and they were a vertical pair. We could do the exact same thing. It wouldn't take long. I don't know, at what point it would have taken exactly, probably step 7. I'm just going to put, step X here. We would also be able to say angle 2 is congruent to angle 3. I'm sorry, 4 rather. Probably for the same reason, congruent supplements theorem. Okay, we're just going to take that time and save it because it would just be a replication of what we just said. So, what do we know? If two angles are vertical angles, then what do we know about them? They must be congruent, okay? And that's what the congruence theorem says. Let's go ahead and say that. If two angles are vertical, then they are congruent. All right, I'm going to stop it there, and I'll pick up a little bit in the next video and do some examples.